containers, DevOps, Kubernetes, orchestration, service mesh, crossplane, and the dreaded platform. Who's heard these buzzwords before? Wow, not even everybody in the room. Why are you here? Most of us get bombarded with these words all the time, and I got my technical terms in, my quota, so my salary is saved. As you may or may not know, my name is Rudolf. I see a lot of people I do know and a lot of people I don't. Welcome, everybody. I've been professionally writing software for about 20 years. Don't laugh. And I've seen tech change over time, like we all do. Even the younger folks among you, which is basically everybody, we're the old folks. Who considers himself old? Nobody. Cool. A couple of young people, a couple of old people. Amazing. But we know how fast things change, right? Languages and frameworks and libraries, they change over time and at a pace we've never seen before. And the changes that we see aren't actually as revolutionary as people think they are. Over all these years, I've learned the more things change, the more they stay the same. We all come to software differently, through universities, online courses, boot camps, and whatever your route is, we all learn the same basic things. We learn variables, parameters, loops, functions, objects, methods, all of those things. And all of these components allow us to weave together the instructions, allow us to bend machines to our will. Some of us even learn the complex arithmetic that makes it possible for what passes for intelligence these days. What we aren't taught, though, and what we have to learn by ourselves through trial and error, is how to operate our software. No traditional institution of higher learning has an operations course, as far as I know, and very few of them bother to expose us to how complex it can be to build software systems, how hard it can be to run software reliably, and how excruciating it can be to trace that one bug in production. It works on my machine, right? So ever since we invented the program, we needed to build more and more complex systems over time. We needed to know how to run these systems reliably, and even the most rockstar developer needs to learn how to debug. Sad part is, these components of the software forge has been ignored by most of our institutions. But happily, those who came before us quickly built tools and expanded on them to allow our systems to run. This second quiet arm of the software world are the unsung heroes. They're called operations. And ultimately, that's what platforms do, and that's what we'll be talking about today. Platforms are about operating your systems far more than anything else. As your system becomes more complex, so do the tools we need to operate these systems. Is that what your system looks like? So when microservices became a thing, all of this came to a head. Operators were used to running 2 or 3 dedicated servers, easy peasy, all good. But now, that single guy in operations suddenly had to worry about hundreds of microservices running in production. This is why Ops also has a completely different purview. Developers develop, but operations also have a different purview. They're responsible for much more than just the code. And their responsibilities far outweigh the average developer as well. Developers care about security, right? When was the last time you worried about how your server was configured? Whether the firewall was allowing the ports through? Whether the correct TLS version was set up? Whether the cipher suites that are chosen for your TLS version are secure? When was the last time you checked for zero-day vulnerabilities in your systems? Anybody? Do you have a date? When the Log4Shell series of vulnerabilities were discovered, was it you who had to quickly fix your Java server, it was the operations team. So the rise of microservices just ended up with multiple teams of developers throwing these complex systems across the wall, and ops had to handle it, worry about it. So yes, I blame microservices for all the we are in. This platform stuff we now have to learn. It seems like it has nothing to do with software or adding value or solving business problems. But operating your software is the only thing that matters. I'm kind of kidding. It's not really just microservices' fault. Microservices give us some advantages, and we can't really deny that. But those advantages are sometimes really important and sometimes not. Keep that in mind. That's how DevOps was born, another buzzword. And because more devs needed to operate their code, the rest of the buzzwords also fell out. Containers. We've all heard of containers. Anybody who hasn't? Cool. We needed those because the dev side of DevOps cannot be trusted with a raw virtual machine. Then we have Kubernetes, which is containers plus plus. Basically just a tool to schedule and place containerized workloads. Infrastructure as code has always existed. Ops have written bash scripts to update and deploy and maintain infrastructure since the beginning of time. But the developers just don't care. We don't want to learn bash. We know Java, right? So tools like Ansible and Chef and Puppet and Terraform were born. And in 20 years, I've seen it all. Well, not necessarily all, but some artistic license, please. When I started my career as a race car driver, I worked for a very, very small company. 3 developers and 1 development manager and no operations at all. We were responsible for everything. We wrote the code, we tested the code, we built the code, we deployed the code, and we operated the code. We didn't use Git at the time. SVN was the rage at the time. And there were no containers, no cloud, and no everything has to be a website mentality either. Technically, browsers and the World Wide Web was in its infancy. And I really, really can't remember which browsers were even available. May have been Internet Explorer and Mozilla or Netscape, but the browser wars weren't even started yet. We built an application, we built it in Java, we served it in Tomcat, and Tomcat did almost nothing. All it did was use Java WebStart to serve a thick client to the users. This is insane, doesn't it sound insane? Who would like to go back to that days? Okay. I had nothing to do with these choices. Just remember, I was a noob at the time. So what did the app do? I think you might want to know. And it's somewhat relevant. It was actually a monitoring tool. So we built a monitoring tool that assisted IT ops teams to manage legacy systems. And when I say legacy, I mean really legacy. Legacy 20 years ago. Right. So things like Lotus Notes servers, Oracle 8, SCO Unix, those kinds of things. We even did a POC monitoring vending machines in the UK using a special GSM device around 2010. IoT before IoT had a name. But we basically just sold off-the-shelf software with support, like many vendors still do. We also built a self-contained Java-based installer that would install on Windows or on Linux, and it would install the server-side components and the monitoring agent, and it would even install the database and configure for you. It would create Windows services and whatever flavor of init your Linux had at the time. It would set these services to start automatically and gracefully shut down and restart when something inevitably went wrong. And the installer was text-based for those systems who were headless and had a GUI for other systems. When I started, there were boxes of CDs, printed CDs, professionally printed CDs, that we would take to the customer and put in the cup holder of whatever server needed to run the software. To be honest, though, CDs went out of fashion in about 6 months, and flash drives were all the rage. They weren't that expensive anymore, and everybody had antivirus software that was top-notch, right? So most of our customers were small businesses, but there were also some big South African names in the list. So Telkom, Bankserv, Bytes. And when given the option of whether they wanted to use SFTP to download our software or whether we should bring a flash drive, the operations team chose a flash drive. They claimed that their firewalls would block the SFTP. I mean, your operations, you could change that, right? Secretly, though, I've always known that bandwidth was the issue. So the operators didn't want to wait for the download. The internet was slow back then, even for big businesses. And that download would interfere with the booming torrent scene that just happened. Every office had a download server in those days, and surely no one could afford the price per megabyte, right? Time is money. But I've digressed about that for long enough. Let's talk about developer platforms. And now my first job would have been completely different had there been platforms back then. So hopefully you all agree that what I was doing was DevOps of a sort, right? We developed and tested and operated and did all of the things that DevOps does. And we did it for multiple clients as well. So the keen item among you might have noticed that the tool that we built is kind of completely obsolete these days because monitoring is part of DevOps and nobody builds their own monitoring tools anymore. But let's forget about that for a minute and just define what a developer platform is. We're in buzzword land, so there's not a single definition that everybody will agree on. So let's try a few out. This is my least favorite one. A platform is built by a platform team to build golden paths and enable developer self-service. This is a self-referential definition, right? Platforms are built by platform teams and platform teams from platforms. That's not great. Platform is a self-service layer on top of an existing engineering team's existing tech and tooling. So that's a little bit better, but we can do better. A platform is a standardized set of self-service tools and technologies that developers need to create and deploy code. We're getting there. A set of tools to automate repetitive and error-prone tasks, a good one. But my most favorite one is by consolidating and simplifying the elements of the development process. The basic objective of any platform is to make a DevOps team's day-to-day work more manageable, efficient, and collaborative. So keep that in mind for the rest of the talk. And then I want to talk about the difference between these three words. What's the real difference? I doubt there really is any, whether it's just a platform or a developer platform or the internal developer platform or IDP, that most people want to call it these days. For the sake of argument, whether it's internal or not, what's the difference, right? And to be honest, we all use Azure and AWS and Kubernetes, so we're not developing them in-house anyway. So it's very, very unlikely that your internal developer platform is actually internal. Thankfully, we don't have to reinvent the wheel. And all the tools and services that we are used are mostly not built in-house. Also notice that most of the definitions don't differentiate between dev and ops and exactly who's doing the work. So let's just consider it a DevOps platform rather than a developer platform. So now that we have a definition, we still don't know what's part of a platform. What do we need? Where does the infrastructure end and the platform begin? And where does the platform end and the software begin? So let's look at the individual tasks that we developers and DevOps operators do, DevOps engineers do. Looking at what we used to do in my first job. So we used to write code, build code, test code, deploy code and its dependencies on multiple environments, monitor environments, including ourselves. And then we had to trace issues through all of these environments, obviously. It doesn't sound like DevOps engineers do that much, do they? But I did oversimplify a little. But we can go into the detail and see what kind of tools are available for developers to actually perform these tasks. So the most dreaded task, and the task that I think all of us enjoy the least, is finding that issue in production. What I used to have to do is I used to download the log file or get the email, like the client to email it to me as a multi-part zip file in separate emails and then put back together. And with all these files safely on my machine, I'd scrape it for the required detail. The tools that I had to use were easy and simple. Cat and Awk and grep, they were my companions while I was trolling through all these logs. And as we scaled the monolith, we just aggregated those individual files into a single file, and we were all done. These days, though, microservices made it hard. No longer did I have 4 files that I just joined together because we had 4 instances. Now we have hundreds of files coming from hundreds of places. And that changed our lives forever. We needed a tool to do this. And I'm sure you all heard about the Elk Stack. That was the first one that really helped us with that. But that has now been superseded by many, many other ones. Next thing we have to do is monitoring. It used to be very simple. I had 4 instances, right? 4 traffic lights or robots, as we call them in South Africa. On a big screen somewhere, everything is green, everything is good. But if you have 1,000 microservices, how hard is that dashboard to write? Multiple tools help us with that as well these days. I think Grafana is the one that most people are using. But what about services that don't always have to be up? What about that billing run that runs once a month on the 25th? It often wasn't on the dashboard, and on the evening of the 24th, someone would do a pre-run. So remember to monitor your things. Deployment is easy, right? It's very simple. But think about how I had to do it. I had to build a jar, then build an installer to install that jar, and install Tomcat, and install all of the other dependencies that we needed. Do we stop the whole process? Do we remove it and reinstall completely? Do we figure out the way to patch the jar? How about the order of the deployment? Obviously, the database needs to be updated before we can bring the server back up, right? Now, the problem is that dev and QA and prod's databases were never the same, and all the careful testing of production scripts that you can do fails, and your script has to go back to dev and get tested again. And once that script runs, remember the server is still down, waiting for this update to happen. Once that script runs, the next one will fail as well. So deployment, it wasn't as easy as it is today. We've all seen deployment pipelines. They're amazing. The more complex the system is as well, the more complex that deployment and those dependencies between deployments are. And I think we all know what red tape can abound when we have to deploy things. We used to have deployment meetings where every stakeholder in the business had to be in the same room and sign a piece of paper that agrees that we are allowed to go to production. Who in the room still has those? Wow, nobody. How about the addictions? Oh, I mean, the dependencies. We're not allowed to call them addictions anymore. Whenever we had to do dependency management, we had to literally do it by hand. Even with Maven and those fancier things that we have, your runtime dependencies aren't part of that. And you often have to worry about that as well. So who worries about consistent builds these days? Look how perfect that pattern is. We had to be able to ensure for IT audits that we had a backup of every version we ever deployed at each of our customers. Right? We didn't have Git. We couldn't go back and say, well, I'll just reset. And we can build you exactly the version you had yesterday. If we lost a backup, we lost the version that this customer was running. Okay. When we updated a dependency or updated a build set, all of that was gone, and we could never go back because it wasn't source controlled the way it is today. Testing has come a very long way. Back then, everything we tested was tested by hand. It wasn't a browser-based thing, so we tried a couple of things to move the right mouse around and click on our client. Didn't work that well. We had JUnit and stuff like that for kind of unit tests, but like integration testing in Oracle database, can you imagine? It took 40 minutes to do the backup and twice as long to restore a backup. A throwaway database to use for your integration testing wasn't a thing. We didn't have containers. And then we get to writing code. I think this is the one that probably was the most solved back then. But how much did you have to install before you could start actually running? I had to have my operating system installed, and then I had to have an IDE installed, and I had to have my JDK installed. Eclipse IDE oftentimes needed some other things to just be in the right spot to work as well. And even Maven and Ant, which were advanced build tools at the time, wouldn't just install and run very easily, especially if you had interesting build steps. These days, however, it's as simple as spinning up a GitHub code env or whatever they call it. So all of the cloud services we have available these days at a price, and the Kubernetes platforms that everybody puts down, has changed the landscape forever. We can develop and operate code in a land of plenty. We are spoiled for choice. Next time you have to merge a pull request, and the entire process of productionizing that single piece, that single change of yours happens automatically, you have to think about what led us to that place and how hard it used to be. When you have a spare moment, look at some of the tools that are available in the platform. Notice that I haven't said Kubernetes is a platform, and that's not what I mean. I mean that any tool that you build yourself or that you can find on the internet to make your daily job easier and the tasks that you do, that is platform. See if you can find some or build some to make your enterprise better. When you don't have a spare moment because you're too busy, consider which of the tasks we should be automating, right? How many people have to wait for a code review before we can actually try out your stuff in QA? Maybe see if we can automate code review. And consider the different tools that are available to spare you some of the time. So none of us are just developers anymore. We all operate software systems, large and complex ones mostly. And all the engineers that came before us and the engineers that call themselves platform engineers today, they're the ones that make our lives just a little bit easier. And that's important to remember. Because I was there during the evolution of this platform, I often forget how good I have it now and how horrible it was back then. Next time that you look at a task that you're doing and you consider how painful it seems, think how bad it used to be and how much easier it is today. And maybe just when you have a second to smell the roses, just think of those engineers that came before you and made your life just a little bit better. Thank you for being at my talk today.